Welcome to Algebra 2 Skills Assessment Review. I'm going to go through each of these problems, highlighting key things that you'll want to watch for, and completing each problem. The first problem you see is squared on both terms. You also see 16, which is 4 squared. So what I'm going to do is I'm going to write each of these terms as an item squared. Notice when I rewrote these, the values never changed. It's still x squared. And if I square 4 and I square b, it is 16b squared. From here we know that the difference of squares is in the form that looks like the first term minus the second term in parentheses, and then we have the first term x plus the second term. A quick way to double check these is to go back through and FOIL them out, and you should be back to your original. Again, we haven't changed the value of this, we've just changed the way that we wrote it. Problem number 2 we see has x squared, an x term, and then a number. That means that we're going to use the AC method on this problem. Our A term is 1, our C term is 4. So A times C is 4. The AC method tells us that these two numbers have to multiply to 4 and add to our B term. Our B term was -5. We think about numbers that multiply to 4. 2 and 2, 4 and 1, both multiply to 4. Now we have to think about what add to -5. Well, since they multiply to +4, we know that both of them have to be positive or both of them have to be negative. So in this case, if we choose -1 and -4, we have two numbers that multiply to 4 and add to -5. Our next step is that we rewrite this equation. So we start with our first term, x squared, and instead of minus 5x, we're going to write that as minus 4x and minus 1x. And then our last term will be plus 4. Notice that this middle term is just rewritten as a combination of two terms. The reason we do this is that we can now factor by grouping. We're going to take our first set and we're going to factor out the greatest common factor. And then we're going to take our second set and factor out the greatest common factor from there. From our first two numbers, our greatest common factor is x. So we have x minus 4 left. On our second one, since it's -x and plus 4, we want x minus 4. We're going to pull out a -1. At this point, we look to make sure that what is in parentheses matches. That means that we're on the right track of factoring by grouping. We pull that out, so we factor that out, and now we're left with this. So one of our terms will be what is in parentheses, and the other one will consist of x minus 1, so whatever's outside the parentheses. When given a problem like number 3, we always want to see if we can pull out a greatest common factor first. When we have 4, 15, and 25, there is no greatest common factor from this, so we go straight to the AC method because it has an x squared, an x, and a number. Identifying our A, B, and C, we see that if we multiply A times C, we get -100. That means we want two numbers that multiply to -100 and add to whatever our B term was, which was -15. I listed a few combinations that multiply to 100. Remember, if it multiplies to -100, one has to be negative and one has to be positive. If we're looking for two numbers that add to -15, the only option is to have -20 and +5. Using these two numbers, we rewrite our original equation using the first term and the last term, and then rewriting -15x as a combination of the two numbers that we chose. Notice what I have highlighted here. If we added these two together, we would be back to our original b value. That means that we chose the correct ones. From there, we factor out our greatest common factor from the first two factors and from the second two items. From the first two, we can factor out an x. We're left with 4x plus 5. And from the second set, we factor out a -5, and we are again left with 4x plus 5. At this point, these two items match. We know that we have selected and done this correctly. From this point, we factor out our greatest common factor from this line, and we're left, which is 4x plus 5, and we are left with x minus 5 as our other term. Problem number 4, we always look for our greatest common factor first. 15, 27, and 6, we can pull out a 3. And when we do, we're left with 5x squared minus 9x minus 2. From this point, we now have 5x squared minus 9x minus 2, an x squared, an x, and a number. So that means we want to use the AC method on this problem. Multiplying our a term times our c term, we see that that's negative 10. We want two numbers that multiply to negative 10 and add to whatever our b value was. Our b value was negative 9. The two numbers that I chose that multiplied to negative 10 and added to negative 9 were negative 10 and positive 1. I'm going to do the same thing that I did earlier and write this as 5x squared minus 10x plus 1x minus 2. And I'm not going to forget about my GCF of 3 that I originally pulled out. From there, I'm going to factor out the greatest common factor from both sets of terms in parentheses. Just looking at my first two terms, I'm going to pull out a 5x, and I'll be left with x minus 2. From my second set, I have x minus 2, so I'm going to factor out a 1 just to put it in a form that we know what to do with it. From there, we factor out an x minus 2, and we use 5x plus 1. And then we cannot forget about our GCF that we pulled out at the very beginning, 3, and that is our final answer. Question 5. Anytime we have a number out front of the y squared or the x squared, we always want to try to factor out a GCF, something that comes out from each term. In this case, we can pull out a 4. We are left with 4xy plus 15y plus 25 in parentheses. From here, we look at our coefficients and we say, there's no more GCFs, so we're going to go straight to the AC method. After making a list, we notice that there's none of these combinations that multiply to 100 and add to 15. That means that this item is completely factored and our solution is given. Problem 6. Our first step is always pulling out a GCF. If we look at these two numbers, 250 and 16, we can pull out a 2. And we're left with 125x to the third minus 8y to the third. We are just going to deal with what's in parentheses. We see to the third power, so we want to rewrite this entire piece as something to the third power. It'd be 5 to the third and x to the third. So we can rewrite it like this. Our second one would be 2 to the third, y to the third. So if we put them both in parentheses and raise them to the third power, we have written it in a different form, but it hasn't not changed the values. We know our difference of cubes factoring special case, which says we take this term and we write what we see. So 5x minus 2y. That goes in our very first spot. Our second spot says we're going to take our first term, which was 5x, we're going to square it, and then we're going to add whatever our two terms were. And then we're going to finally add our last term squared. From there we do some simplifying. We square 5, which is 25, and we square x, which is x squared. Combining in here, we multiply 5 and 2, which is 10, and that's still times x times y. And then we have 2y squared, which is the same as 4y squared. And this is our solution. Our first step on any problem is factoring out the greatest common factor, and in this case we can factor out a 4 and an x. Now that we've factored it out, we have two options. If the coefficient here is 1, we don't necessarily have to use the AC method. You can use your guess and check method that you've used before. So we look at the sign, it's negative, so one has to be negative, one has to be positive, and the two numbers have to add to -1. And we must remember our GCF. If we don't have 3 terms and we have an x to the third, our initial thought should be, let's use a special case. We see that 8 rather could be written as 2 to the third, and we still have x to the third. And we are going to be adding 27, which is 3 to the third. Rewriting this in a form that we're used to looks like this. Remembering our special case, we always write what we see, 2x plus 3. And then we say our next term is 2x squared, and then since this was plus, we go minus. It's our 2 terms multiplied together, and then it's finally adding our very last term, which is 3 being squared. Doing some simplifying, we square 2, so we get 4. The x is also squared. We subtract 6x, and then we're going to add 9. And that is our final answer. Again, our first step is always to pull out the greatest common factor. In this case, we can pull out an m. When we pull out an m, after you pull out an m, you may be thinking that, oh, these terms are squared. Remember, we don't have a special case that says if we're adding squares. We only have it if we're subtracting squares. So we are finished. When looking at problem 10, there's 4 terms. That should immediately cue you to factor this by grouping. That means we're going to look at the first 2 terms and pull out a greatest common factor, and then we're going to look at the second 2 terms and pull out a greatest common factor. Our greatest common factor from the first set of terms is 8r squared. When we pull it out, we are left with r minus 8. If you notice on this problem, I actually made a mistake here. This x should be an r. So if we're pulling out a number, we're going to pull out a positive 1, and we're going to be left with r minus 8. These 2 match, so we know we're on the right track. From there, we pull out the r minus 8, and then we take what is left, which is 8r squared plus 1, and that makes up our other term. Problem 11, we're just given 2 terms. We know we cannot factor it by grouping, and we cannot use the AC method. So that means we want to look and see, is there a special case that fits this? X to the 6th and y to the 4th can both be written as powers squared. X to the 6th can be written as x to the 3rd squared, and y to the 4th can be written as y squared squared. And then we take 10 and we write it, or 100 rather, and we write it as 10 squared. A little rearranging, and we have now written it as a difference of squares. Remember, our formula says we take the first term, which is 10x to the 3rd, and we subtract the second term, which is y squared. And then we write the exact same thing, except instead of a subtraction, we have an addition. And we are finished. Our final problem for factoring gives us 4 terms and asks us to factor. If it gives us 4 terms, we should automatically snap to grouping. We want to factor out the GCF from the first 2 terms, and then look at the second 2 terms and factor out the GCF from those 2. The first 2 terms, we pull out a 7x. We are left with 8y minus 5. My second 2 terms, I can pull out a positive 2 and an r, leaving 8y minus 5. It's always a good double check to make sure that these 2 match, because then we can take it and write that term, and then our second parenthesis is made up of what is left outside, and that is our solution.